Hello everyone. In previous lecture, we discussed the solutions of alkali metal in non-aqueous solvent. On an exam, sometimes they ask explain the solutions of alkali metal in ammonia. In that topic, we discuss when metal dissolve in ammonia to form ammoniated cations and ammoniated electrons, and they are the good conductor of electricity. After that, we discuss some reaction related to this dissolution. That means when the sodium is dissolved in liquid ammonia to give the solution that is blue when diluted and bronze when concentrated. Up to this we cover in previous lecture. Today we will start the remaining part of alkali and alkaline earth metal, that is application of crown ether in the extraction of alkali and alkaline earth metal. The crown ether is also known as the macrocyclic polyether. The macrocyclic, that means the large or big molecules. It is a protic solvent and it is used in the SN2 reaction. The best example is DMSO, dimethyl sulfoxide, HMPA, hexamethyl phosphoramide. Now, these crown ethers are the polydentate ligand, and we know the ligand is the Lewis base which donate the electron pair, in which the ligating atom having used for the separating metal atoms, having used for the separating alkali metal ion. The polyether, this is ether type linkage. Here carbon, oxygen, carbon, that means the polyether of this type are called as the crown ether, and they are cyclic ether having mostly the repeating ethylene unit with oxygen. Here the best example is 12 crown 4 ether. Here 4, that means here 4 oxygen, this 1 2 3 4, 4 oxygen, and remaining is repeating ethylene unit, that means CH2, here CH2, here oxygen, again CH2, oxygen, CH2, oxygen, here CH2, again oxygen. Okay, this is 12 crown 4 ether. Now then 15 crown 5 ether. Here 1 2 3 4 5 oxygen, and remaining is CH2 ethylene unit. Therefore this is 15 crown 5 ether. Why this is 15? Because here total number, that means oxygen and the carbon, here atoms are total 15. If we start from this one here, okay, this 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Therefore this is 15 crown 5 ether. Another example, here 18 crown 6 ether. 6 ether, that means 6 oxygen. Here 1 2 3 4 5 6, and remaining ethylene unit, that means CH2, here connectivity. Therefore this is 18 crown 6 ether. Now then 21 crown 7 ether. 21 crown 7 ether, that means here 7 oxygen. Here 1 2 3 4 5 6 7 oxygen, and here again it is connected with the CH2 ethylene linkage. Therefore 21 crown 7 ether. Now then dibenzo. Why it is dibenzo? Because here two types of, here two benzene ring, here first and this is second. Therefore dibenzo 12 crown 6 ether. Here 1 2 3 4 5 6 oxygen. Therefore dibenzo 12 crown 6 ether. Now this is single benzene ring. Therefore benzo 15 crown 6 ether. These are some examples of the crown ether. They are preferentially used. The most commonly used the 12 crown 4 ether. Now in crown ether, all the oxygen atoms of this ether inward toward the metal ion of macrocycle have unusual property of forming stable complexes with alkali metal ion. The bonding of metal polyether is largely electrostatic, and the exceptional stability of complexes is associated due to the heating of metal ion in whole of ether. Here the tabular form, here cations, now then ionic diameter and polyether ring and hole size in angstrom. For the first cation is Li plus lithium, the ionic diameter is 1.52, while for the polyether ring it is 12 crown 4 ether. The best example is the 12 crown 4 ether and the hole size in angstrom is 1.20 to 1.50. Now then for Na plus it is 2.04 and the polyether ring is the 15 crown 5 ether and hole size 1.70 to 2.20. Now then for K plus, here 2.76 and the polyether ring is 18 crown 6 ether and hole size is 2.60 to 3.20. Now then for rubidium, here the ionic diameter is 3.04 and the polyether ring involved 21 crown 7 ether and the hole size is 3.40 to 4.30. By using the proper crown ether, only one metal ion can be extracted in organic solvent by keeping other alkali metals in aqueous phase. That means when you use the crown ether, having the two phases, that means the organic phase and aqueous phase. And when by using the proper crown ether, the only one metal ion can be extracted in organic solvent by keeping other alkali metal in aqueous phase. Now, the extraction ability of metal ion is enhanced by the addition of counterion with large molar volume like picrate dinitrophenol thiocyanate. That means if we enhance the extraction ability of the metal ion, we have to add the counterion. When you add the counterion, at that time the extraction ability of the metal ion is enhanced. Here the best example is here Mn plus 18 crown 6 ether. In first step is complex form between these metal, that Mn, and this 18 crown 6 ether. Here we get the metal 18 crown 6 ether, here N plus. Now then next step, if you add the counterion like the picrate molecules, picrate dinitrophenol thiocyanate, here there is the replacements, or here the picrate, the counterion, it form the complex with the this 18 crown 6 ether. That means here we get the metal M 18 crown 6 N plus picrate. Okay. Now the another examples, here 221 cryptate, 221 cryptate, here 221 1, that means here only one oxygen atoms, that mean between the two nitrogen, and here remaining again we know the structure of the crown ether, here again remaining same, the repeating unit of the ethylene molecule CH2 CH2, here CH2 CH2, again here CH2 CH2, oxygen, here CH2 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 CH2, here nitrogen, here again CH2 CH2, again CH2 CH2, here 2 2 1 1, that means here in between two heteroatom, here again one, only one oxygen, therefore 2 2 1 cryptate. And in case of the here 2 2 2 cryptate, why it is 2 2 cryptate? Because in between these two nitrogen, here two oxygen, and remaining are, this is cyclic, and here remaining are here nitrogen and here oxygen, here ethylene unit, that means CH2 CH2, here oxygen, here again CH2 CH2 oxygen, again CH2 CH2, here nitrogen, CH2 CH2 oxygen, here again CH2 CH2 oxygen, here CH2 CH2 nitrogen. That means here continuously the repeating unit of ethylene molecule. Okay, and here repeating the procedure with different crown ether and counterion. Metal ion are separated dibenzo 12 crown 4 ether, benzo 15 crown 5, and dibenzo 18 crown. The alkaline 18 crown 6 ether are preferentially used in alkaline earth metal can be formed the stable complexes with the crown ether and cryptate, and these are also used to extract the separated alkaline earth metal. That means crown ether is the most important for the extraction of alkali and alkaline earth metal. So friend, never miss a video. Subscribe to my YouTube channel. I think you are getting the application of crown ether. So friend, thank you.